Hello, sir. I'm Dotan Lon, and this is my video presentation for Cloud Foundations Assignment 2. My student ID is ST9756161, and he's the ID. Okay. And in order to enable a scalable, secure, and highly available web application environment, I create a cloud-based architecture using AWS for this assignment. From creating the foundation infrastructure to utilizing various AWS services to launch both static and dynamic websites. The work is broken down into 7 tasks. In task A, will be VPC and networking setups. I started by creating a unique virtual private cloud with the name S3975161, and I set up two availability zones, one for private resources and one for public facing resources, and assign a CIDR block. Next, I make 4 subnets. The first 2 subnets is public subnet A and public subnet B in separate AZS. Available zone stands for available zones. And the second one is the private subnet A and private subnet B in the same availability zones. So to enable internet access, an internet gateway was connected to the VPC. 2 routes table were set up by me. The first one is the public route table for 0000 cross 0 traffic to the IGW and is associated with the public subnets. And the second one is the private route table has no outbound route to the internet and is associated with the private subnets. So the isolation between instances are visible to the public, and backend elements like database is guaranteed by this configuration. So we'll turn to task B in a static websites. I started an AC2 instance in one of the public subnets for this task. To make it accessible from the internet, I gave it an elastic IP address. I add a security group that permitted access via SSH port 22 and HTTP port 80. I built up a user data strip that installs Apache, downloads an example static website from a public SC links, unzips it, and configures the web server using Amazon Linux 2 as the IAM. I was able to use the elastic IP to immediately access the static site after the instance was up and run. Yeah. So here is the website. I will access this here. Yes, here. So is the website from the link. Yeah. Okay. Uh, so next we'll go to the task C. About the static website on Amazon S3. I uploaded the static website files, made a new S3 bucket, and turned off public access blocking. After that, I make static website hosting possible by designating error.html as the error document and index.html as the index document. I add a bucket policy that permits S3 get object for all objects in the bucket in order to make the website public. So after that, I will use the endpoint URL that S3 has given me to visit the static websites. Okay, so here's the link to the website. So here's the link. Yeah, so I can access it. Okay, next is we'll talk about the task D, static website with Elastic Beanstalk. I use AWS Elastic Beanstalk to install these identical static websites for this assignment. I chose PHP as the platform. Make Made a new application environment and upload the website zip file. EC2, load balancers, and auto scaling were among the resources that Beanstalk automatically supplies. The website went live at the environment URL that Beanstalk had supplied in a matter of minutes. So here's the link of it. So just post it here. Here. Okay. We'll turn to the task E, load balancer and auto scaling group. So I developed a launch template based on Amazon Linux 2 with a user data strip that installs and set up Apache and the static website in order to make it scalable. I then constructed an application load balancer and a target group that uses index.html to verify the health of EC2 instance. I then use the launch template to set up an auto scaling group. I set the intended compatibility to 2 instances with a minimum of 1 and a maximum of 3. I decide I designed it to publish subnet. After I was finished, the load balancers will divide traffic among 2 availability zones to 2 healthy EC2 instances. So here is the website. Oh, sorry. Okay, run. Okay, it's working now. So, okay, we'll talk about task F, the dynamic websites with RDS. Here I use a user data strip to set up a new EC2 machine in a public subnet to run an inventory application build with PHP. After that, I set up a private subnet RDS MySQL instance to house the backend database. I set up security groups so that the RDS database on POP 3304 could only be accessed by the EC2 instance. After the database was prepared, I made sure the dynamic website loaded inventory data from the database by connecting the EC2 app to RDS. So here's the website. Here, okay, is the inventory website. Okay, you can add some items in here you want. Okay, so next is the strategy, the architecture diagram. So this is the final step. I will create a diagram to illustrate the full architecture. So first one is a VPC with public and private subnets across 2 AZS available zones. Yeah. And the second one is a static website search via EC2, S3, and Elastic Beanstalk. The third one is the load balancers and auto scaling group handling high availability. And the final one is the dynamic web app on EC2 connected securely to the MySQL RDS instance in a private subnet. So in conclusion, I gain a in conclusion, I again like a lot of understanding on how to use AWS basic services like EC2, S3, RDS, and vPC, load balancing, and elastic beanstalk to create a scalable and secure architecture. Thanks to this assignment. Okay, thank you for listening. So later on, I will post the presentation video link in here. Thank you guys for listening.